Ever stood near a glowing charcoal stove and felt the intense warmth baking your skin, even without touching it? Or maybe you've left a metal spoon in your morning tea, only to burn your fingers when you picked it up. This happens because heat naturally moves. It flows in one constant direction, traveling from a hotter place straight into a colder one. This invisible flow of energy continues until both objects reach the exact same temperature. Once they balance out, the movement stops. This journey of heat happens all around us in three distinct ways: conduction, convection, and radiation. By tracking these three invisible travelers, we can control our surroundings, whether that means cooking a meal efficiently or building a home that stays cool in the afternoon sun. Conduction is how heat travels through solid objects. While the energy travels from one end to the other, the solid material itself stays exactly where it is. If we zoom in super close, solid objects are made of tightly packed particles. When you heat one end of that solid, the particles there absorb the energy and start to violently vibrate. Because they are packed so tightly, those shaking particles physically bump into their direct neighbors. They pass the heat energy down the line, particle by particle, exactly like handing off a baton in a relay race. Some materials, like metals, are excellent at this relay race. We call them good conductors. Other materials, like wood or plastic, are terrible at it and block the energy flow. We call those insulators. This is why we make cooking pots out of conductive metals to move heat quickly into our food, but we attach insulating wooden handles to stop that heat relay before it reaches our hands. In liquids and gases, the particles are spread further apart, so they can't bump into each other easily to conduct heat. Instead, the heated particles have to physically carry the energy themselves. When water is heated at the bottom of the pan, those particles gain energy, expand, and rise. As hot water moves up, cooler, heavier water sinks to take its place, forming a continuous circular convection current. We see this same circular movement on a massive scale at the shoreline of Lake Victoria. During the day, the sun heats the solid land much faster than the deep lake water. As a result, the air sitting right above the land heats up and rises rapidly into the sky. That rising hot air leaves an empty space behind. Instantly, the cooler, heavier air sitting over the lake rushes inland to fill that gap. That refreshing breeze rolling off the lake is convection in action. It is the engine that drives our local winds and weather. Outer space is completely empty, with no particles to bump into or circulate. This means the heat from the sun can't reach us by conduction or convection. Instead, heat travels through space as radiation. These are invisible waves of energy that don't need any physical particles to travel. Every hot object emits these waves. Dull, black surfaces soak up these waves perfectly, but shiny or bright white surfaces act like a mirror, bouncing the heat waves away. This is why many buildings in Kampala have bright metal roofs to help them stay cool under the intense daytime sun. If you look at highly flammable fuel storage tanks at petrol stations, they are armed to overheat. Because radiation can leap across empty space, choosing the right color for our tools and buildings is a matter of safety in a hot climate. To see how we can fight all three of these travelers at once, we use a vacuum flask. It is a piece of engineering built specifically to keep your tea hot by stopping heat from escaping. First, the plastic stopper is a poor conductor, blocking heat from traveling up. Inside, an empty vacuum gap lacks particles, stopping heat from crossing by conduction or convection. Finally, the silvered glass walls act like mirrors, bouncing invisible heat rays back into the liquid. By trapping all three invisible travelers, the flask keeps its contents hot for hours. On the scale of our entire planet, the atmosphere works in a very similar way. It naturally catches some of the heat radiating off the ground, keeping the Earth warm enough to support life. Waves of energy from the sun pass through the air and heat the ground. The Earth then tries to radiate that heat back out into space, but certain gases in the sky catch those rays and hold them near the surface. But when we cut down trees and forests like Mibera, we increase the amount of these gases. This effectively thickens the blanket of air, catching more heat than should be staying here. That extra trapped heat drastically changes the convection currents flowing in our atmosphere. This leads to severe droughts and unpredictable rains that make it incredibly difficult for farmers to grow food. From the hot tea in your flask to the cooling winds blowing off the lake, heat transfer is the invisible force shaping our lives and our climate every single day.